Hello. Oh, I've got questions already. Right. Okay. I'll just wait in case anybody else who was there. This might be quite short today. We've only got one more of these left, by the way, so we'll do one more next week, and then I'll be done. Um, 5, 6.3, 8.3, 8.6 from the year 10 booklet. Yep, fine. I've got quite a lot of questions from the year 10 one, which is this, I believe. It's quite difficult, this, by the way, because we are just throwing you into GCSE papers, but that is the experience that you get. I've only got questions from the year 10 one so far, so if anybody has any others, then tell me, because I do have the other one here as well. Okay, I'm going to start with just the few questions that somebody asked me, and then if there's no more, then there won't be any more. But this is a typical question that you guys will get at the sort of beginning of chemistry, I think is the best way to say it, which is how to make a pure, dry crystals of something. In this case, it is copper sulfate. Now, the first thing to get right is that the metal oxide that you're going to use depends on the metal that you have here. So if it's copper sulfate we're trying to make, then we're going to mix copper oxide to, now we need an acid. There are only three acids that you ever need. There is hydrochloric acid, I'll write it down. There is sulfuric acid and there is nitric acid. Now, when you react something with each of those, you get something chloride if it's hydrochloric acid, something sulfate if it's sulfuric acid, and something nitrate if it's nitric acid. Which means that if I'm trying to get to copper sulfate, I'm going to have to use sulfuric acid. Okay, that's the first thing that we need to get right. Get the two things that we need to mix together. Correct. You've got to mention you've got some equipment here, so I guess you would say in a beaker. Yeah, if you want to just mention that. Um, okay, the next thing, which I'm not going to go into too much detail with, what you need to do is you keep on adding the copper oxide until it is in excess. That means that there's more of it than what you actually need. And what you're trying to do here is you're trying to make sure that all of the acid finishes and reacts. The only way you can make sure of that is by adding loads of the other thing. So in excess means there's more of it than what you would need. So you add the copper oxide to the sulfuric acid until the copper oxide is in excess, until there's more of it than what you need. So what you effectively have now is a beaker in which when you react copper oxide and sulfuric acid, just so you understand, let's write this down. What you're going to get is copper sulfate, that's the thing you want, plus water. So what you're going to get in this beaker now is these two things, which is copper sulfate and water. But because you added loads of copper oxide, you're going to have some of it still in there that hasn't reacted. So there's going to be in here some unreacted copper oxide that we never used. And what we're trying to get to is just this by itself. When we say a pure dry crystal, it means there's nothing else in it. So we don't want the water, we don't want the extra copper oxide. So now what we have to do is gradually get rid of the things that we don't want. So what we're going to do, because copper oxide is a solid, it's a powder, we're going to use our filter funnel and filter paper to pour our solution into there. And what's going to happen is that the copper oxide that we didn't use is going to stay up here and the rest of it's going to go down. So use the filter paper and funnel to remove the excess copper oxide. Okay, so now what you're going to have is a solution that is only copper sulfate and water because you've got rid of the copper oxide that you didn't want. So, but we still now need to get rid of the water. How do you get rid of the water from here? You heat this, and you normally heat the solution in an evaporating basin. That's why there's an evaporating basin pictured here. You could have said other things like mix it with a stirring rod and all that sort of rubbish. And what that does is it evaporates the water. And what's left behind then? Just the copper sulfate. And all you do is you leave the copper sulfate to cool, and you will end up with pure dry crystals of copper sulfate. That is how you would go about doing that. You've also asked for 6.3, which is explain why copper, this is quite a complicated question. Explain why copper is formed with the cathode during the electrolysis of its salts. Well, I'm going to simplify this part because you haven't done much electrolysis, I appreciate. But the cathode is a negatively charged electrode. Okay, and copper forms a positive ion, a Cu2 plus ion. So what happens during the electrolysis is the positively charged copper ions are attracted to the negatively charged electrode because opposites attract. And that's why we get copper forming on the negative electrode. If you haven't done electrolysis, this won't make much sense, but that is what the answer is. Then we've got this lovely question. This is an equation for a reaction of titanium chloride with sodium. I mean, this is a really easy question. You shouldn't really be asking this, but I'll tell you the answer. For one reaction, 1,615 kilograms of this stuff reacted with 782 kilograms of sodium to make 1,989 of sodium chloride. Calculate the mass of titanium produced. Well, the numbers on the left-hand side should add up to the numbers on the right-hand side when we're talking about masses like this. So on the left-hand side, I've got 1615 plus 782, which is a total of 2397. On this side, I've got something add 1989. So if I just take away 1989 from that, should get the answer. 408. 8.1, 8.3. Oh, I'm not doing 8.3. You've got to plot a graph. Oh, sorry, that's 8.2. 8.3. Okay, this is a bit difficult to do because what I'll do is I'll use the answer to help me because I need the previous answer for it or the graph. Actually, no, I don't. No, I don't need the graph, sorry. So what they're telling you is that this much sodium chloride dissolves in this much water. 36 kilograms dissolves in this much water. The question is, how much water do we need if I've got this much sodium chloride? So more, obviously, because it's a bigger number. But how much more? You need to figure out how much bigger this is than this by doing 1989 divided by 36. It's 55.25 times bigger. Okay? Which means that I need 55.25 times as much water, which is going to give me 5525 as the answer to that question. It's like a maths ratio thing. That's what really the question is. Um, 8.5, again, I'm just skimming over the questions here, but what do you know about argon? What should you know is that it is in group zero of the periodic table. What does group zero tell you? Group zero is unreactive gases. Okay, so argon is in group zero. So it is unreactive. Um, and why would you do a reaction in that instead of in air containing water vapor? Well, it presumably is because if you do it in air containing water, then something in your reaction, I don't know what the reaction is, but something in the reaction could react with that water and you don't want it to. So I think it's the sodium in this question. So argon's in group zero, so it's unreactive. But air contains water and oxygen, which could react with the reactants. So we don't want these things in our reaction to react with anything else. So that's why you might do it in a gas that's completely unreactive. That's the main knowledge that you want from there. Um, and then the last question, why titanium conducts electricity? Right. Whenever you get a question about any metal and why it conducts electricity, the answer is always the same. Okay, so this could have said copper, it could have said something else. Why does this metal conduct electricity? It's because all metals have delocalized electrons. That's the first thing. Delocalized means free, and it means that they can move around. Okay, so we want to get another mark for saying that. Delocalized electrons, which are free to move around. And if they can move around, they can carry the charge through from the structure. So if that's the piece of titanium, I've got these free electrons here. They can take electric charge from one end and move to the other end. And that's what conduction is. It's just the movement of electricity. Okay. And that is all of that, which I think is all the questions anybody asked me. 5, 6.3, 8.1, 8.3, 8. It is. Right. As I said, for just for the remaining this week and next week, which is the last couple of sessions, I'm just turning up to answer any questions that anybody has got. And then you've got holidays now. I suspect nobody will come next week anyway because they'll all be on holiday. But we have a lesson. Sorry, we still have lessons as normal till the end of the month. These Wednesday sessions will be next week, and then we won't do one the week after. Just so you know. But otherwise, if you're, well, all of you, most of you are on the weekends, you will be have your next two lessons as normal. Um, and then that will be it. Right. On the basis that nobody has any other questions for me, I am going to end it there, very short. But if you do have any other burning questions, then feel free to WhatsApp us and stuff, and we can always arrange another time. But yeah, otherwise, oh, there's more. The tests should all be marked now, so I suspect you'll just get them on Sunday. I just think it takes a while to mark the tests because they're so long, but I suspect you'll have them on the this weekend. Yeah, they should do. If you don't, tell me. But I think they should all be marked by this weekend. Right. That's it then. Assuming there's nothing else, I want to let